Welcome to Care Coordination and Interoperable Health IT Systems, Principles and Technology of Interoperable Health IT, Lecture B. This unit will cover the following learning objectives. Number 1. Name and define types of interoperability. Number 2. Explain the complexities of semantic harmonization and the benefits of using standards. Number 3. Describe and contrast intra- and inter-organizational interoperability. And number 4. Identify and discuss common types of tools and technologies used to solve health interoperability problems. In this lecture, we will be covering intra-organizational interoperability and inter-organizational interoperability. You will be able to describe intra-interoperability and interoperability. You will also be able to compare and determine differences between these two concepts. Imagine a typical intra-organizational data flow. On this picture, I show 4 common hospital systems: a patient administration system, an EHR, a laboratory information system, and a clinical data warehouse. Each of these systems typically shares data with each other. Often the interface type within an organization is transaction feed-based. This means that when a transaction occurs on one system that represents an event of interest to other systems, an event-related message is created and fed to the interested system. For example, when a patient is admitted, the registration is recorded on the patient administration system. A patient admission event is of interest to other systems. When the patient administration system records the admission event, it also generates a patient admission message, which it sends across the interface to an interested system. Downstream systems in this case, the EHR, the clinical data warehouse, and the laboratory information system would all receive the admission message. Receiving systems listen to the feed and processes messages about each patient administration event recorded on the patient administration system. Within a single organization or enterprise, it is easier to be generous in data sharing because you do not have a need for intra-organizational consents or agreements. Within an organization, there is a limited scope on the amount of data being communicated on interfaces. It is scoped based on the number of patients being cared for in the enterprise. Therefore, it is acceptable for the receiving system to get information by listening to a transaction feed-based interface and consuming all of the data, even if some of it will not be used by their system. A lab system does not need to know about patients that do not have lab tests. Yet, in a hospital, the lab system has a database containing all admitted patients, which it builds using the patient administration feed. For example, when the lab system receives a patient discharge message, it already has a record of the patient's visit and simply marks the patient as discharged. When the lab system receives an order from the EHR on the orders feed for an admitted patient, it already has a record of the patient visit and knows their current location in the hospital based on information it stored from the patient administration interface. The lab will know what hospital room to send the phlebotomist to collect the specimen based on the most recent location information it received from the patient administration system. In contrast, this would not work in the inter-organizational context. Imagine a community lab storing information about every patient in the community that could ever potentially have lab work. Within an organization, you can usually establish a single owner or assigning authority of a particular kind of data. Owners are sole creator and updater of a particular kind of data. In a hospital, it could be established that the admissions office owns patient administration data, and the system they use to record patient administration data is the patient administration system. The IDs generated by that system, like a patient ID or a visit ID or a provider ID, can only be generated by that system. Demographics and visit data can only be updated on the patient administration system and no other system. The admissions office might also have some value sets that they are responsible for, such as admission types, for example, inpatient, emergency, ambulatory. If admission types are changed, the changes must be done on the patient admission system. The electronic health record, the system used by the clinicians, would own data that clinicians collect. It would also generate unique IDs for things like clinical documents or orders, and it would own those IDs. It would own clinical information that is being collected by the clinicians, like the medication administration record, doctor's orders, or clinical notes. The electronic health record would also own the value sets for types of orders and documents. The laboratory information system would own its own IDs, like the ID representing every filler order, which is its turnaround document back to the doctor saying that it will carry out the test. The laboratory information system would also generate and own a unique ID for each result and each specimen accession. It would also own all of the lab result findings and the lab result charge. There are value sets that are going to be laboratory-driven, like the laboratory catalog of tests, specimen types, and abnormal flags, which would be owned by the lab. You will notice that the clinical data warehouse has nothing that it owns. That is because the clinical data warehouse's function is to take information from all of the different systems. That data is then processed, analyzed, and used in aggregate to create aggregate views and information. You can say that the clinical data warehouse owns that aggregate view. For example, it can come up with quality metrics that need to be communicated to the government or to organizational executives. The clinical data warehouse would own that aggregate view of information. So why is data ownership such a big deal? Imagine ownership of demographics is shared between System A and System B. Imagine both systems allow you to update demographics and both can send each other demographic updates. If the same data is updated on both systems and then sent to the other, there is a chance that one system could overwrite the other, and an update would be lost. Now, another case would be if only System A sends updates, but both systems are allowed to do updates. Then, anything that is done on System B is eventually going to get overwritten by System A. If you are able to actually choose a data owner, then these problems can be avoided. When one system owns the data, then only the data-owning system is able to update the data, and other systems must make requests of the owning system to perform an update on their behalf. Now, there are special situations even when you do establish ownership where you might have to have some workaround like downtime. What happens if the system that owns the demographic data is down? How do you collect that demographics information? But these are exceptional situations that you develop something special for. It is important to understand data ownership because what you are going to see when we look at inter-organizational data flow is that it gets more complex because it is harder to establish a single data owner. So appreciating that clear data ownership is a real benefit of being within a single organization is important. Now let's go on and talk about inter-organizational data flow. This becomes a lot more complex because a lot of those things that we knew about intra-organizational data flow no longer apply. In this picture, we have two different doctors' offices that are communicating, and the doctors are also communicating with the laboratory, the public health authority, the insurance company, and the pharmacy. One of the first problems with inter-organizational interoperability is patient identification. There is no longer a central system that owns patient information that is feeding the patient identification information to all the other systems, which you are able to have within a single enterprise. There is not a single enterprise identifier since you are now communicating between organizations. Patient identification becomes a real problem. It is critical to be able to identify a patient so you can locate his or her records across enterprises. If you cannot identify the patient, you do not know how to tell other locations that you are looking for records on a specific patient. You now need to have a shared patient identifier that spans multiple organizations. You will need to match patients across a community, a region, a state, etc. Health information exchanges always have EMPI technology to do this type of matching across organizations. There are also other shared identifiers that would need the same correlating across organizations, such as provider IDs and organization IDs. EMPI health information exchange tools and technology can be used to manage these problems. These technologies are covered in a later lecture in this unit. Another inter-organizational challenge is that terminologies differ between organizations. In a single organization, there can be a single agreed-upon terminology and value sets that are often owned by specific departments, such as the lab. In the inter-organizational setting, each organization will have its own local terminologies, and each organization will consider themselves owners. Terminology differences are a barrier to communication across organizational boundaries. When you compare across organizations, you might even have the same code meaning two totally different things. Even if it says, quote, glucose, unquote, glucose can mean different things on different devices. While maintaining terminology is hard in one organization, the maintenance and history of terminology across organizations is much harder. Being able to trend and look at data over time can be especially difficult in the inter-organizational data flow situation. It becomes especially important to use standard terminologies. While standards really help, standards are often adopted differently at each organization. Mapping is required, so ideally there is a community-level terminology surface to map terms between organizations. This exists in health information exchanges. Terminology services and HIE tools and technology can be used to manage these problems. These technologies are covered in a later lecture in this unit. There is no longer a clear authority as you would have with a single organization. It is unclear who is responsible for resolving problems. For example, imagine if it is discovered that a patient has been mistakenly identified as the wrong person. While this is difficult to solve in a single organization, numerous organizations would need to be involved to resolve this in the inter-organizational context. Any change is difficult in an inter-organizational setting because no one organization is an authority over the others. So it is hard to set rules for data ownership and quality management. And without a single owner of a dataset, you are at risk for lost updates if the same dataset is sent from two different systems. Additionally, the atmosphere is competitive, not collaborative. Therefore, there is less trust, which leads to less data sharing. Maybe an organization will only send required fields outside of its organization because you now need to make sure you have consents aligned and business associate agreements in place. Organizations are very wary of HIPAA breaches, and you might be sharing with an organization that competes with you for patients. Therefore, there is a need for regulatory support and intermediaries to establish rules and facilitate inter-organizational interoperability. Transaction-based feeds are often no longer appropriate since it is no longer a closed dataset. Data flow tends to be pull-based or subscription-based. That is, when information is needed, a query is sent to obtain it. Alternatively, a receiving system might receive feeds, but only for those patients they cared for. The receiver would subscribe to receive feeds for specific patients. Instead, a pull-based or subscription approach makes sense. Let's talk about this a little more. Using the transaction-based feed model that is common within an organization, a doctor would log into the EHR and examine lab results about a patient that he is caring for. The organization's EHR would have lab results for all patients in the organization, but the EHR would query its own database and present only the results appropriate for the patient the specialist was treating. However, imagine a doctor in a private practice that uses a commercial lab. The commercial lab does not send out its transaction feed of every lab result to every doctor that uses the lab. It might allow the doctor to subscribe to receive results for his or her patients or allow the doctor to query the lab. Also, receivers often require a lot more information sent because they have less historical context for specific patients. Recall that when a lab receives an order for the intra-organizational setting, it already knows a lot about the patient from the patient administration system. However, in the inter-organizational setting, the lab does not know anything about the patient. It does not receive a feed of patients from all of the doctors that send orders to it. The lab cannot do that because they would not have the processing capacity or storage capacity for it. In addition, according to HIPAA, they do not have the right to the patient's information until the patient is in their care. The lab would instead need all of the patient demographic information sent along with the order, or would need to do a query for the additional information. Another difference between intra-organizational data flow and inter-organizational data flow is that the reason for the data flow between organizations often represents an official transition or handoff between organizations. For example, the patient may be discharged from an acute care hospital for a long-term rehabilitation center, or the patient might be referred from a primary care physician to a specialist. The information exchange, instead of being a series of messages, would instead be a formal, cohesive, official document. Examples include a discharge summary, discharge instructions, summary of care, etc., which would contain all of the pertinent clinical data for the next provider of care. To support inter-organizational interoperability, widespread adoption of standards is essential, and the variances in standards implementations must be minimized. This can be done by having everyone implement the same implementation guides that specify how to use standards for specific contexts. This is discussed more in Unit 5. We are beginning to see changes in financial models that are making sharing a benefit and not a burden. Laws are now beginning to require inter-organizational sharing, with information blocking now discouraged. We need to support structures to keep the sharing functioning, such as interlinked IT service desks and data quality reviewers, to be able to do things like merge duplicates and keep up with terminology changes. You need to change management if any system is changing their code or their interface. You need to share functioning for upgrades and communication. These inter-organizational interoperability support structures do exist today in a limited fashion in the health information exchange organizations. The biggest challenge of all is the change in organization, process, and workflow such that healthcare stakeholders successfully benefit and improve care at lower costs. This concludes Lecture B of Principles and Technology of Interoperable Health IT. To summarize, we described and contrasted intra-organizational interoperability and inter-organizational interoperability. Intra-organizational interoperability is the exchange of information between systems in the same organizational context. It is characterized by single owners of data, clear patient identification, generous information sharing, and transaction-based feeds in which receivers remember context. Inter-organizational interoperability is the exchange of information across organizations. In contrast to intra-organizational interoperability, inter-organizational interoperability is more complex, since there are multiple conflicting data owners, multiple patient IDs, more formality requiring for data sharing, more data formats, more information required by receivers to determine context, and cross-organizational management challenges.